just trying to figure these slides out. Yeah, so as Carlo mentioned, I work on the warehouse and fulfillment team here at Rent the Runway. Our warehouse is out in Secaucus, and I guess this is going to have to do.
What's the next to the exit?
Sorry?
On the bottom next to the exit button?
All right, thanks, Gene.
And click around.
Yeah, this works. Yeah, so my name's Aki, as Carlo was saying. I work in the warehouse and fulfillment team here at Rent the Runway. Our warehouse at this point, I think it's 160,000 square feet, and there's a team, most of whom are sort of scattered around this room, who work on this custom suite of software that the warehouse staff uses to do their job. Just a little background. So I'm going to talk about Drop Wizard and RabbitMQ and the software that we've used, like focus on the queues that we've put in place. But just to set expectations correctly, it's not going to be super technical. I want to talk a little bit about our architecture and sort of the approach that we've taken to designing that architecture. And there's going to be a few Drop Wizard specific notes, technical notes, and sort of architecture design notes. But I sort of was hoping to open the floor up for discussion at the end about designing around queues and that kind of stuff. But first, I'm just going to talk a little bit about the warehouse operations itself, to just give you a little bit of context. So as Carlo was mentioning, we do have a typical pick, pack, ship workflow in the warehouse where people are picking dresses off the rack, putting them in boxes, putting labels on them, and sending them to UPS. But every dress that goes out has to be returned eventually, because we're doing rentals, not just selling the dresses. And so that has this whole huge twist where, rather than returns being an exceptional case that you have to handle for some 10%, 20%, I'm not sure what a normal e-commerce site does in returns, but we do 100% returns. And so that makes the workflow in the warehouse a little thorny, and it means the software has to rise to the challenge of supporting their workflow. The other twist that for our business in particular, just the nature of, I honestly don't know if it's the nature of us renting dresses and the fact that it's fashion and there's hot styles, but there are thousands and thousands of packages that get returned on a given day that need to be opened, processed, and then the dresses inside those packages shipped out the same day. This causes, I think, this is the source of most of our complexity in the software and in the warehouse's workflow, just because they are constrained by literally how much they can run the dry cleaning machines. There's just, you can't run them 24 hours a day because they don't have staff or because they'll literally break down. And so they need to prioritize what stuff, which dresses they dry clean, which UPS packages they open, and so on. And so the other side of this coin, I think, to talk about that makes this challenging is that we, as a internet company in 2015, are trying to do best for our customers, and we have I think everybody has some expectations from internet companies nowadays that you're going to be able to go in and find your order page, cancel your order, change your address, add another dress to your order, and so on. And this causes, or I should say, it poses some challenges for us as a company and as a tech team to build software that both supports all this, but also gives our customer service staff and our warehouse staff the tools to manage the problems that come up. And so speaking of problems, there's of course lots of problems that do come up, specifically when people are late with dresses, or UPS is late, or dresses get damaged. We need to have a way for both our customers to not have a terrible experience of the fact that they're being called by customer service saying that your dress is damaged and we're not going to send it out for your event tomorrow, we'd like to do that earlier, but also so that the warehouse staff and the customer service staff have tools to sort of gracefully manage these problems. So the brief history, I don't know if Carlo mentioned it earlier, but we have now this much larger suite of software for all of our Rent the Runway tech that is service-oriented, Java backends, Java web services that are are talking to the database and serving the actual renttheronway.com. The warehouse software is similar in that we have a suite of Java services, but it wasn't always this way. We used to have just this monolithic Spring web application, which later turned into a Spring Web Service that was serving a Ruby JavaScript and HTML web app. So the software used to be much simpler. It was like the warehouse didn't have, like they were simply shipping fewer addresses, and their workflow was much simpler. That obviously has changed over the years, and as just in order to serve those needs, like the software's had to evolve, as of course most businesses are hope to have to evolve their software. What we're going to be talking about today is just this back-end Java layer. The database I'm not going to talk about at all, and the front end is like just not really a component of this this talk. And for our software in the warehouse, this is like the core of where the business logic is. And so I wasn't here when this happened, but at some point we grew to the point where we needed to like introduce specialized web services for certain parts of the warehouse's flow. And when that happened, I think that the developers at the time made the frankly very pragmatic choice of just saying, well, this service needs to talk to another service. We're going to use HTTP because it's like well understood. I don't even know which the first service that had to do this. So we had this old Spring Web application that is still around, but at some point it needed to make effectively a remote procedure call to another service, and they picked HTTP. I don't even know which service that was, but I'm going to pretend it was the allocation service because it's the one I'm familiar with. So we have these two data sets, which I'll talk a little bit about, but the big one in the warehouse is inventory. We're managing inventory. We're keeping track of where inventory is, the state of inventory, what inventory is available, and what inventory is, where it is physically, both in the warehouse as well as we have a bunch of showrooms throughout the country. And so keeping track of that is like a very important part of our software. And so at some point, we have some inventory management going on in one service. We want to notify the other service that some inventory has changed. Either it's moved, it's been damaged, or something like that. And the authors used HTTP to make that call. And as, of course, software always, there's always some new thing. We got to the point where we need to introduce another service. And so, again, I don't actually know the exact history of which services were introduced, but I've just sort of come up with this narrative that maybe it was this assembly service, which is not like assembly language assembly, but actually assembling multiple dresses in a given order together physically in one place before they're packed. So it's part of the pick, pack, ship workflow I mentioned earlier. At that point, the authors decide, well, just throw another HTTP call. Like, it's not that big a deal. They're all like, we'll just put another post. It's like you've got, literally in your code, your Java code, you're just like, you have a couple of HTTP clients, you're just going to make a second call to this other endpoint. It doesn't really matter if it's in another service. It can't get that bad. But of course, as the software grows, we add more, the authors add more services. And now you have this situation where on every inventory change, you're making like 4, 5, 6 HTTP calls to these other services. And obviously that gets like really out of hand. Specifically, when you have, so in this picture, the sort of idea that these color boxes on the right don't really matter. You can just imagine this be microservices or web services that are owning specific parts of the warehouse's workflow. The purple one on the left is supposed to just be this data owning service for the inventory data. And there's this problem where what if one of these requests fails? You've already made some successful requests. You're going to make hopefully some successful requests later. You're sort of stuck in this non-transactional scenario where you have made some change to your data. You want to publish that change to your downstream consumers. But HTTP could be used to do this, but you're going to have to come up with something on top of this in order to implement this safely. And I think this is kind of interesting from an engineering and like startup and business perspective, because this clearly worked actually for a very long time. Like the warehouse was able to ship out thousands of dresses using this software. The business was able to grow to the point where we are now, where we're doing 25,000 dresses in a week on our peak time. And I think it's one of those cases where like, you know, it's sort of good enough, but obviously there's a point when you know the software, this architecture can't be relied upon to handle our scale, and the scale specifically being like there's just such a volume of inventory going through the system that you're going to end up with data inconsistencies that could have been repaired manually in the past, but now it's just like it gets to a point where it's too difficult to do manually. So architects at RTR chose RabbitMQ. Like I said, this isn't really going to be very specific to RabbitMQ. Most of the stuff I'm talking about would apply to like any other message queue system. I think we have not really had any problems with RabbitMQ, but these are just, I mean, some details. It's an open source message broker. It implements this advanced message queue protocol that I think a couple other message queues use. It's written in Erlang that like doesn't really, we don't write plugins for it, so I don't really know much about how that impacts the user of RabbitMQ. There are tons of clients in lots of languages. We use Java. I've used other clients in other languages for testing, but I think at RTR all of the actual communication with RabbitMQ is done through the Java client. In terms of, there's these two data sets I was talking about earlier. In the warehouse, the way this is done, and we're not the only users of RabbitMQ at RTR. There's a bunch of other uses of it that are probably some of the more interesting and could be a whole different talk. But for us, we're really interested in these two data sets, reservations and inventory. And so the primary job of the warehouse is to take these reservations that customers are booking and fulfill them. And we're fulfilling them using the inventory. So it's sort of like the core business problem decomposes into these two data sets where you have you know, reservations on one side, like future reservations, as well as like reservations that need to ship out today or need to ship out the next few days, and your pool of inventory that you're using to sort of solve this problem. And the changes that are happening to these data sets are like not that interesting. It's just like the normal kind of CRUD operations where customers are booking new reservations, they're changing the details of the reservations because they are, you know, their event is going to be in Las Vegas instead of New York, or their event moves the date or so on. And the inventory changes as well, of course.